Hi, my name is Donghyun Kim, and this is my lightning talk for my honor thesis on exploring intra-object composition using scene graphs and diffusion models. In my thesis, I proposed a problem of intra-object composition, which entails merging multiple distinct source object features into a single coherent entity. So an example of this would be integrating robotic legs into an antique chair. So in this case, we are integrating an attribute of a robot, which is its legs, into a completely different object, like an antique chair. And by doing so, we can achieve creative possibilities because it allows the generation of entirely novel out-of-distribution designs. So my progress this semester, um, I first established a baseline using Stable Diffusion 3.5 and LoRa Dream Boost, and by doing so, it demonstrated the challenges of complex intra-object compositions. And we've also made enhancements like cross-attention loss and data augmentation, and by doing so, we achieved improved feature alignment and coherence in our baseline. And finally, we explored LoRa modularization, where each attribute, such as a head or body of a robot, and the relation, such as the head being on top of the body, is trained with a separate LoRa layer and selectively used during inference. So for a more detailed explanation about the LoRa modularization, we have prompts like asset zero head on top of asset zero body, or asset one head on top of asset one body, which is the different objects that we have. And we also have like separate assets without the relations. And we can maximally utilize our data by training separate LoRa layers for each of the attributes and relations that exist in the data that we have. And during inference, we can just selectively choose um, each attribute and relation that we want in our result image. So for the results, here's an example where I trained Stable Diffusion to create an image of a robot with Baymax robot head and Wild Robot's robot body. And this would be the result with the prompt, a photo of a robot with asset zero robot head and asset one robot body. And these are the results in different environments. So first one would be skiing in a snowy mountain. Second would be lying on a beach suntanning. And finally, throwing a baseball. And this is another result with an antique chair and robot leg. And in this example, I wanted a new image with the antique chair body and the legs replaced with the asset one robot leg. So here's the result with the prompt of photo of a chair having asset zero chair body with asset one robot leg in a house. So we can see that indeed that the antique chairs robot legs are replaced with the robot legs that we have, and yeah, so that's the results that I have for this semester using our baselines. And the next semester plan is to focus on joint LoRa training to improve modularity and efficiency. And we will also conduct comprehensive evaluations using qualitative and quantitative metrics and benchmark against state-of-the-art methods. And finally, using all the results that we have, we will prepare a publication detailing our findings and applications in fields such as industrial design. And yeah, that was my lightning talk. And thank you for listening.